This video will cover one of the gas laws, Boyle's law. To begin, what is Boyle's law? In a general sense, it is the relationship between pressure and volume. More accurately, it defines how volume and pressure are inversely proportional at a constant temperature. As volume increases, pressure decreases. The first example uses a syringe. When the top part of the syringe, known as the plunger, is pushed inward, the volume inside the barrel decreases. This means the contents, like gas, are compressed into a smaller space, increasing the pressure inside the syringe. The next example uses a beloved marshmallow. If pressure decreases, causing air to expand in the marshmallow, you can logically deduce that the marshmallow itself would also expand. For a better visual aid, here is a demonstration that combines the previous two examples by placing a marshmallow in a locked syringe. First, place a marshmallow in the syringe. Next, push the plunger just above the marshmallow, with some room. Then, plug the end of the syringe. By pulling on the plunger, the pressure inside the syringe decreases. If you look closely, as the pressure is decreased, the marshmallow grows in size. On the other hand, when the plunger is pushed down, the molecules within the marshmallow get closer together as the pressure increases, causing a decrease in volume. The final example is breathing. When you exhale, your chest cavity compresses, decreasing the volume in your lungs. The decrease in volume applies an increase of pressure in your lungs that causes air to be pushed out, allowing you to exhale. However, when you inhale, your chest cavity expands, increasing the volume of your lungs while decreasing pressure. The decrease in pressure draws in more air, allowing you to inhale. The first and most frequently used equation for Boyle's law is P1 times V1 equals P2 times V2, where P represents pressure, V indicates volume, and the numerical values 1 and 2 respectively indicate whether they are initial or final values. The additional equation is written as PV equals K, which represents the product of pressure and volume as a constant called K. For the purposes of this video and lesson, only the first equation will be used. To demonstrate working with the equations, let's complete practice problem A. It goes as follows: a gas has an initial pressure of 6 atm and an initial volume of 4 liters. What is the new volume of the gas if the pressure drops to 3 atm? First, recall that the equation to use is P1 times V1 equals P2 times V2. Let's begin by defining each term in the equation according to the word problem. The initial pressure, P1, is stated to be 6 atm. The initial volume, V1, is 4 liters. On the other side of the equation, the final pressure, P2, is 3 atm, and the final volume is unknown. We must solve for final volume, V2. Now, we can substitute the values into the equation accordingly. After substitution, the equation will read as 6 times 4 is equal to 3 times V2. On the left side of the equation, 6 multiplied by 4 simplifies to 24. Following algebraic rules, you must divide both sides of the equation by the coefficient, 3, to isolate V2. That leaves the left side with 24 divided by 3, totaling to 8. The final volume of the problem is equal to 8 liters. Next, try this practice problem on your own. A gas at 25.0 degrees Celsius was at a pressure of 1.00 atm. Later, pressure increased to 2.50 atm at a volume of 1.44 liters. What was the original volume of the gas? Pause the video. Then, click play to reveal the answer after a 5-second countdown. 5, 4, 3, 2, 1. The answer is, the initial volume is equal to 3.6 liters. Did you get it right? As valuable as solving hypothetical problems are, Boyle's law also has real-world applications. In the real world, Boyle's law is essential to understanding the human body. For example, it provides an explanation for our respiratory system, as seen in example 3 earlier in the video. This alone has allowed medical advances, like ventilators. Ventilators use Boyle's law in manipulating pressure in the lungs, causing it to inflate or deflate. The same logic can also be altered and applied in the context of scuba diving to accommodate for the diver's breathing and equipment. The law is also significant in more commonly seen discoveries such as hairspray, tires, and cabin pressure in planes. Thank you for watching.